Hello everyone, welcome back to my channel. Nice to see you and thanks for clicking this video. So today we're going to learn about sequence and series. And let's get started. Before we go into the topic, let me introduce my teamwork. There are three people. First, Azara as the second presenter. Second, Nadira as the third presenter, and the last one, it's me, Sarah, as the moderator and the first presenter. In this video, the topic is sequence, the formula for the nth term, recurrence relation, arithmetic sequence, arithmetic series, the sum of an arithmetic series using sigma notation. And the last, examination style question. Sequence. In mathematics, a sequence is a section of numbers scale terms that follow a given rule. For example, 9, 16, 25, 36, 49 is a sequence square numbers start with 9. A sequence can be infinite, as shown by the at the end of the sequence shown above, or it can be finite. For example, 3, 6, 12, 24, 48, 96 is a finite sequence containing 6 terms. A sequence can be defined by formula for the nth term of the square or a recurrence relation together with the first term of the sequence. The formula for the nth term or the general term of a sequence is often given using superscript notation as UN. The first term is then called U1. The second term is U2. The third term is U3. The fourth term is U4. The fifth term is U5 and so on. Letters other than U can be used. For example, the terms in a sequence will also be given by T1, T2, T3, T4, and Tn. Any term in a sequence can be found by substituting its possession number into a given formula for UN. For example, the formula for the nth term of a sequence is given by UN equals 4n minus 5. Find the first 5 terms in the sequence. U1 equals 4 times 1 minus 5 equal minus 1. U2 equal 4 times 2 minus 5 equal 3. U3 equal 4 times 3 minus 5 equal 7. 4 equal 4 times 4 minus 5 equal 11. U5 equal 4 times 5 minus 5 equal 15. The first 5 terms in the sequence are minus 1, 3, 7, 11, and 15. Recurrence relation. This sequence can also be defined by a recurrence relation. To define a sequence using a recurrence relation. We need the value of the first term and an expression relating each term to a previous term. For the sequence -1, 3, 7, 11, 15, each term can be found by add 4 to the previous term. We can write 1 equals -1, u2 equal u1 plus 4 equal 3, u3 equal u2 plus 4 equal 7, u4 equal u3 plus 4 equal 11, and so on. In general, un plus 1 equal un plus 4. Recurrence relation together with the first term of a sequence is called an inductive definition. So, the inductive definition for the sequence -1, 3, 7, 1, 15 is u1 equals -1, un plus 1 equal un plus 4.
I am Azara Muadifa. We'll continue the presentation. Now we will discuss about arithmetic sequence. In an arithmetic sequence or arithmetic progression, the difference between any two consecutive terms is always the same. This is called the common difference. For example, the sequence is 8, 11, 14, 17, 13. An arithmetic sequence with 3 as the common difference. The common difference we get from 11 minus 8 equals 3. So 3 is the common difference. If we call the first terms of an arithmetic sequence a and the common difference is d, so we can write a general arithmetic sequence as a, then a plus d, a plus 2d, a plus 3d, a plus 4d, etc. The nth terms of an arithmetic sequence with first term a and the common difference is d, we get a plus n minus 1 times d. The inductive definition of an arithmetic sequence with first term a and common difference d, we get u equals a, then un plus 1 equals to un plus d. So, what is the formula for the nth terms of the sequence 10, 7, 4, 1, minus 2? This is an arithmetic sequence with first term a equals 10 and common difference d equals minus 3. Common difference we get from 7 minus 10 equals to minus 3. So d equals to minus 3. So the nth term is given by a plus 10 minus 1 times d, and because a equals 10 and d equals minus 3, so un equals to 10 minus 3 times n minus 1. Minus 3 times n is minus 3n, and minus 3 times minus 1 is 3. So un is 10 minus 3n plus 3. Then we get un is 13 minus 3n. Now we will discuss about arithmetic series. The sum of all the terms of a sequence is called a series. For example, we have the sequence is 1, 3, 5, 7, and 9, while 1 plus 3 plus 5 plus 7 plus 9 is a series. When the difference between each term is a series is constant, As in this example, the series is called an arithmetic series or arithmetic progression. For the short, we call is AP. The sum of a series containing n terms is often denoted by Sn. So for the series given above, we could write as 5 equals to 1 plus 3 plus 5 plus 7 plus 9. So we get S5 is 35. When n is large, a more systematic approach for calculating the sum of a given number of terms is required. So now we will discuss about the sum of an arithmetic series. This method can be applied to any arithmetic series of the general form is a plus a plus d plus a plus 2d plus a plus 3d, etc. to a plus n minus 1 times d. A is the first term in the series, d is the common difference, and n is the number of terms. Let's call the last terms L so that we get L equals to A plus n minus 1 times D. So that's all for me. The explanation about this topic will continue with Nadiratul Husna.
Thanks. Before I will continue the next explanation about the sum of an arithmetic series. The sum of the first n term in an arithmetic series is Sn equals n divided by 2 times a plus l, where a is the first term and l is the last term. If the last term is not known, this formula can be written in terms of a and n by substituting a plus n minus 1 times d for l above. An alternative formula for the sum of an arithmetic series is Sn equals n divided by 2 times 2a plus n minus 1 times d. Using sigma notation, when working with series, the Greek symbol summation, the capital letter sigma, is used to mean the sum of. For the example, sigma summation r start from n equals 1 to n ur represent a finitive series containing n terms like u1 plus u2 plus u3 blah 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 plus un. Examination style equation. The sum of the first three terms of an arithmetic series is 21 and the sum of the next three terms is 66. For the first question, find the value of the first term and the common difference. The second question, write an expression for the n term of the series un, and the last question, that find the sum of the first n terms. The answer for the first question, the sum of the first three terms can be written as a plus d plus a plus 2d equals to 3a plus 3d. So we can write 3a plus 3d equals to 21. This equation divided by 3, so we get a plus d equals to 7. This equation we call the first equation. The sum of the next three terms can be written as a plus 3d plus a plus 4d plus a plus 5d equals 3a plus 12d. So we can write 3a plus 12d equals to 6a. This equation divided by 3, so we get a plus 4d equals to 22. A plus 4d equals to 22 we call the second equation. The next step, we subtract second equation to the one equation, like 3d equals to 15. So this equation divided by 3, we get d equals to 5. We input d equals to 5 to the second equation or to the first equation, so we get a equals to. The answer for the second question, in general for an arithmetic series, un equals a plus n minus 1 times d, so we can write un equals 2 plus 5 times n minus 1, so we get the result is 5n minus 3. For the third answer, that u10 equals 5 times 10 minus 3, so we get un equals to 47. Now, using the formula, Sn equals n divided by 2 times a plus l, with a equals 2 and l equal 47. So we get S10 equals 10 divided by 2 times 2 plus 47. So we get S10 is equals to 245. That's all our presentation today. Thanks for watching. Don't forget to like, comment, and subscribe. See you in the next video.